Thank you. So, yes, thanks very much for the intro. We can begin. Let's begin with the slides. So, thanks everyone for joining. Or good morning, wherever in the world you might be. The talk today is I'm sharing a story of a migration. Really, we migrated a workload from VMs to containers, and you've probably heard, lots of these stories. Only this one has something different, something in particular about the workload that we're migrating, and that workload is CI, which not everyone realizes that it's a production workload. And not everyone that Sky also has its own customer. The customers, the people who are relying on the service, and this is really the development teams. The people writing the tests also have, you're also the customers of that.
Sorry, looks like we have some issues with the network. Yorgos, could you say something else, please?
Yes, hello.
So looks like we have some issues. Let me check what we could do in such situation. So maybe we should reconnect. Just a moment. Just a moment, okay. So Ruslan, I think we could reconnect Yorgos and then proceed.
I believe yes. So we are now switching to Russian, back to Russian. И пока Yorgos переподключается, я вот, собственно, хотел тогда узнать, ты же здесь как эксперт сидишь не просто так?
Не просто так.
Ты, наверное, все-таки курировал этот доклад.
Как ты сказал, я член ПК Heisenbug.
Расскажи немного, может быть, о том, как вообще происходит ревью доклада, и вот было ли что-то интересное с Yorgos'ом?
Я скажу, что с Yorgos'ом мы познакомились еще в прошлом году. Собственно, я готовил с ним этот доклад, да, мы его ревьюили, смотрели, и я уже, в общем-то, использую в работе то, что подсмотрел в этом докладе, потому что почему-то тема параллельных пайплайнов, она на самом деле не столь, может быть, очевидна или популярна, хотя, казалось бы, все на поверхности, да. Но тем не менее, не так много девопсов знают, каким образом распараллелить пайплайн и как его сделать быстро. Обычно смотрят, каким образом уменьшить количество тестов, либо, соответственно, как-то оптимизировать. В данном случае это нам очень помогло.
Я вот чего-то не понимаю. Мы на конференции Heisenbug, а не на конференции DevOps. И вот мы тут говорим про DevOps, а как тогда доклады Yorgos'а относятся к нашему, к тестированию все-таки?
Руслан, я вот скажу тебе так. Я когда-то занимался, да и, собственно, сейчас занимаюсь разработкой, да. Я, в общем-то, вышел из Java разработчиков, в какой-то момент перекинулся в C#, это уже как хобби, да. В принципе, я менеджер. И мне, как разработчику, было не очень понятно, чем занимается, собственно, тестировщик. Понятно, они там тестируют что-то, да, там посмотреть, в принципе, То есть даже обсуждались идеи о том, нужно ли вообще как звено тестирования. И в какой-то момент именно конференция Heisenbug открыла для меня такое количество различных видов тестирования. В общем-то, я посмотрел совершенно по-другому. Сейчас я абсолютно уверен в том, что тестирование является вообще основополагающим таким шагом, значит, в разработке. И, собственно, пайплайны, quality gate — это основное, что для меня, например, как для менеджера, да, то, чтобы я понимал, какого качества продукт, я не могу этого узнать каким-либо другим образом, кроме как по каким-то метрикам, quality gate, delivery time и тому подобное. Поэтому с точки зрения отдела качества я как раз смотрю на время, которое затрачивается на разработку, и, соответственно, то качество, в котором выходит. Поэтому это такая смежная штука.
Давай тогда, может быть, чуть-чуть заспойли нам доклад, что нас ждет в ближайшие там в ближайший час, и как эти знания помогут нам ускорить и доставку софта, и проверку его качества, и вот это вот все.
Это практический доклад. Его можно, собственно говоря, брать себе, что называется, на вечер, брать его на следующий рабочий день, открывать и просто повторять по шагам. Через час вы будете знать, каким образом прийти, настроить свой Jenkins таким образом, чтобы ваши тесты просто... Вот так как у вас сейчас уже есть пайплайны, да, собственно говоря, вы посмотрели час доклада, час-два настройки, и у вас выход на следующий environment происходит в 2 раза быстрее.
Прям во времени в 2 раза быстрее.
Во времени,
в смысле,
да.
количество сил, действий.
Опять же, есть некоторая разница между тем, как докладчики готовятся к российским конференциям и вообще в России, да, и как международным. Разница заключается в том, что когда докладчики выходят на европейскую конференцию, очень много есть слайдов такого маркетингового, да, и в принципе, когда даже Йоргос к нам пришел, первое, о чем шла речь, о том, каким образом можно сэкономить денег на том, чтобы ускорить пайплайны. В принципе, нас как технарей это мало волнует, да, деньги, понятно, волнуют, но в принципе, вот. Йоргос, говорят, уже готов.
Да, поэтому давайте попробуем его подключить.
Let's switch to English.
Okay, so Yorgos, we will try to turn you on here. We're waiting you on air.
Okay.
Nice.
So please
Okay.
proceed.
Can you hear me any better now?
Yes, we hear you well.
Okay. Okay, let's hope that will be the last of the problems with internet on Crete. I left this off at CI being a production workload, right? And for this to be considered a production workload, it's important to define the customers of this production workload. And a lot of people don't realize that the development team is the customer. So the same people who are writing the test code base, they are also consuming it. And that's why it's important to treat it as a production system, especially so because CI provides this service that it allows you to maintain flow. It allows you to stay focused and keep working on the problem you're trying to solve with kind of the regression testing helping you with a kind of I haven't broken something I didn't mean to as a service along the way, right? So I can keep focusing on my specific problem, ignoring the other, making sure that nothing else is broken in this code base. That's how it allows us to maintain flow, and we briefly went through this introduction. So my name is Yorgos Saslis. I'm based on Crete, and I work for Red Hat. And basically, the automation that I'm working on is kind of a boring term, and I like to think of myself as kind of finding things that people no longer want to do, and finding machines to do those same jobs, right? So I help bots find jobs. I work on the 3Scale team, and a couple of words about 3Scale. 3Scale is an open source API management project and product. And what that means, this API management, is it allows you to create it's basically a piece of software that you can put in front of all your APIs whenever you have another customer on the other end who wants to consume those APIs. So when you want to integrate two systems and there's some kind of commercial relationship between how these APIs can get used, so you have like monthly usage plans and with rate limits and kind of billing, invoices, analytics, developer portals and all that stuff. That's what you can get from 3Scale. So, not pitching any product, it's open source, you can go use it. Some history about 3Scale, because it's relevant for this discussion, is it started off as an independent startup. At some point, it got acquired by Red Hat. And when Red Hat acquires a company, they say, I don't care if your source code is open or closed. Now you have to make it open source, which is kind of scary when you first hear it. But it lets you, it kind of helps you focus on the kind of open source landscape and what CI needs that has. Because open source projects need CI, and they probably need CI more than closed source projects do. Many contributors will come to a project and we use open source software all the time, and we find some small problem and we want to contribute some fix. Usually that's the vast majority of open source contributions, right? Small fixes that fix some kind of particular behavior that the maintainers hadn't kind of covered yet. But that's really hard to do if you don't have a good CI system in place, because you're always worried that your PR might be kind of breaking things, that you're not writing the code in the coding style that the maintainers expect, that you're kind of not keeping any code conventions, and so on. So if all of these things are coded in a CI pipeline, those are kind of things that make contributions be less daunting, especially for new contributors or first-time contributors to this project. CI kind of helps lower this entry barrier. Now, let's go back to that point where that journey for the migration from VMs to containers started, and talk a little bit about the setup we already had. We did have a CI system in place, and it was pretty good too. So there was a single Jenkins master that was fully, it was provisioned with a bunch of scripts, makefiles, Terraform, so that all that part was automated. The config of the Jenkins master was already in source control, so we'd never lose it. All the jobs were in job DSL and another GitHub repo, so everything in source control. Pretty decent setup. Not every team out there today can claim they have something like that. At the time, we were running about 10 to 20 builds per day, with a team that at that point we expected it to grow, and it did grow after that. We were using a bunch of Jenkins workers on EC2 VMs, basically, that we would auto-scale up and down. 2 Jenkins executors on each machine, and kind of 4x large machines, of which we had a number of. And each executor with 8 cores and 32 gigs of RAM. With all that in place, we had managed to bring our builds down into around 15 minutes. In terms of 15 minutes, like real world minutes, human minutes. In those 15 minutes, we were consuming about 11 hours worth of CPU time, using about 45 cores and 90 gigs of RAM. Right? And if you're wondering now how we managed to fit 11 hours into 15 minutes, the answer, I'm afraid, is not that we found a solution that allows us to bend space-time, but rather that, much more boring answer, that we had some kind of homegrown parallelization there. Empirically, we knew how long different parts of the pipeline take, and assigned them to different Jenkins executors. I want to take a step back from the story now and talk a little bit about this, about what we mean when we say parallelizing test suites or pipelines and so on. Because speaking with a lot of people about this subject, as I have been doing, different people understand different things. It's a little bit of an overloaded term. So I want to separate this parallelization in 2 levels. First up, we have creating different test phases within a kind of larger pipeline, right? So that's the one kind of level of parallelization. On the other hand, we have within one of these phases that we created before, we might still have large numbers of tests that we want to run in parallel within that phase. Okay, so in that first phase where we're separating test phases and kind of grouping them into an orchestrated pipeline, we usually find independent tasks that we can run in parallel. A good example of that is, for example, linting or static code analysis, which don't necessarily have to, they don't necessarily have to run before unit tests or integration tests and so on. So independent tasks allow us to create these different phases, but also the other thing you'll find if you look at test code bases is some kind of grouping of tests, the tests themselves, depending on how long the tests take to run. So it's very common, I've seen it many times in test code bases, that there are some annotations like add fast or add slow, add integration, or add unit, without wanting to go into those definitions of unit integration right now. But lots of teams manually tag each test depending on how long they expect the test to take. So we have some tests that can run in seconds. So we can run hundreds or thousands of them and expect them to finish in seconds. Those are the really fast tests that some people also call unit tests. Then we have kind of longer running tests that we can expect to finish within a few minutes in this kind of commit phase. And then we might have other tests that are far more expensive and take a lot more time to run in hours or sometimes even days, that we would probably not run with every commit, but kind of on a different stage altogether. Now, that was the kind of first kind of parallelization we can create in a CI pipeline. The second one is when we're now within one of these phases and we want it to finish as soon as possible, right? So we have 1,000 tests and we wanted to take these 1,000 tests and kind of somehow group them, create groups. So just in this example here, we have group 1, 2, 3, 4, right? Each with a subset of all those tests. So for example, of all our integration tests, we've split them into 4 groups. And of course, the problem here is that when we're looking for feedback about whether our latest commit is still working or it hasn't broken anything else, we need to wait for the result of all four groups. So it doesn't matter that this and this and this, the first 3 groups finished earlier than group 4. We always have to wait for the slowest one. We'll come back to this point later on, but for the moment, kind of keep in mind that we have these 2 different levels of parallelization, okay? Phases and kind of then within the phase. So moving back into story mode, this was now one of those rare moments in life that you happily look back on and you realize that we now have some time to fix some tech debt. The thing that's been slowing us down all this time, now we've been given some opportunity to go in and fix it, right? So we created a list of all the things it was absolutely essential to go in and fix. And the first on that list was build queues. Even with the parallelization we had done before that you saw on that previous slide, even with using multiple EC2 VMs, we still had some budget constraints that we couldn't use an infinite number of EC2 instances. The cost was just too high, and this led to the problem that if 2 people were working on their code base at the same time and wanted to run builds on our CI system, this would lead to some queues getting created. And, when other people were also piling in, build queues and basically slower feedback and, problem. Context switching again, which is what really hurts us thinking earlier about the flow discussion, right? We want to absolutely maintain flow. And when people are in the zone, don't let CI get in their way. Give them feedback as soon as possible. So build queues was exactly causing that problem. That's what we wanted to fix. We can come back to the reasons why we had build queues later on in the questions if people want to find out more about it. Now, the second problem was random test failures. I'm sure many of you will have experienced this problem. I certainly have in most of the projects I've ever worked on, which are also called flaky tests, right? Is a common name for this problem, which is basically non-deterministic behavior. You run the same build, or what you think is the same build, and on the first run it fails, on the second run it passes. We were having at least one of those every day, and the failure had nothing to do with the change being introduced, right? That was fairly clear. As kind of good engineers, the fastest solution to this problem was to rerun the test suite. We even had Jenkins kind of automatically rerun it whenever it failed, right? Which is another common thing that many teams do when faced with these tests. And this allowed us to quickly, without investing too much time to actually fix the problem, to work around it. Of course, that made the situation with the build queues that we just talked about even worse, because the additional builds were getting added to that queue, right? A test failure for a single change set in Git, maybe we have 2 or 3 builds, making the situation much worse. Then another problem that anyone who's ever kind of dealt with Jenkins maintenance or kind of spent time maintaining one because nobody else wanted to do it, you've probably faced this problem, especially when we don't just talk about Jenkins itself, but all the plugins, new versions of those plugins kind of breaking and functionality. Losing some functionality, losing some config that you previously had in some version. I mean, it's a nightmare, which is pretty obvious from what you can see here on the Jenkins release notes. You can even see for each release the number of people who had a problem upgrading to this particular version. Right? I mean, if you need to have something like this in your release notes, it's a pretty good indicator. It's something that people are struggling with. And I mean, these two went fine. This one, not so well, right? 29 people here had a problem. I absolutely, don't get the wrong idea, I absolutely love Jenkins, right? But this is one of the problems and downsides of maintaining your own Jenkins server. The final problem was just the sheer costs of AWS. So even with having some budget limits, we still had build queues, and we were getting at around €2,500 per month. But the important thing here, which I want to kind of stay on for a moment, because I want to let that really sink in, I don't think everyone realizes, is that the cost of kind of a suboptimal CI pipeline, or one that's really slowing down people as much, is not just what it costs you on the cloud, right? It's also the maintenance costs because of Jenkins maintenance, for example, or whatever other CI system, self-hosting, right? All the maintenance costs. But the most important thing is down here at the bottom. The dev team slowdown. when your CI system forces people out of their flow, that's really costly. We all know context switching is one of the kind of biggest pains for teams out there today. So if you add up these costs, it's really not just the €2,500 per month. You have a much, much, much larger problem. So with this kind of ammunition and kind of wish list of things to fix on our back, we then kind of went out and put a kind of shopping list together for things we wanted to address and fix. First up, we with becoming an open source project, 3Scale at the time, we wanted to have publicly accessible build information. Right, we were going through this transition where we would start having external contributors, and we wanted those to be first-class citizens. We wanted them to have full access into build logs. If they opened a pull request to contribute something to our project, we want them to be able to see if the tests passed, if not, why not, and kind of also be able to quickly debug so they can bring us more and more contributions, right? That's just respecting your contributors, which you see a lot of Red Hat. At the same time, we did have some budget, so we were willing to spend that budget so that the builds from our own team, from the 3Scale team, would go in as fast as possible. And from that last point, we did want, obviously, builds from forks to be possible. That's how external contributors would run their builds. But we didn't want Red Hat to pick up that build. Because a funny thing happens with things like that. When you offer to pay for someone else's kind of compute, right? You're running whatever's in those pull requests. It's only a matter of time before people start mining Bitcoin on your pull requests. And this, did happen. The 3Scale team did have this problem in real life. So we wanted to kind of be on the safe side with that. In terms of options we had at that time, obviously we first considered some of the internal systems at Red Hat. We do have, with such a large engineering organization, we have internally teams that focus on solving just the Jenkins maintenance problem. You can find internally at Red Hat managed Jenkins masters, and kind of not just managed on the Jenkins level, but also the plugins, the plugin versions that are verified to work with that Jenkins master version that you're using, right? So a big part of that management problem is solved if you go to one of these. However, this isn't such a good fit because all these systems are on the internal Red Hat network, so all behind the Red Hat firewall, and it doesn't blend very well with this use case that we're talking about now, which is external contributors, kind of publicly accessible systems, and publicly accessible build logs, or even worse, running other people's pull request code inside of our network. So some network security people were really not happy with that idea for very good reasons. Luckily, the public CI solutions today are several, more and more are coming out every day, and they're really this competition between them as well also helps create some really good solutions in this space that we also knew from other projects. So at that point, we kind of stepped out and kind of looked at these public CI systems as how good a fit they would be for this use case. And first up, we wanted to look at the developer experience for getting to the build information. So we have a pull request here on the left in GitHub, and from this UI, it's very, very simple now with one click to just go to the public CI interface where you can see the test pipeline with all its different stages and status. And when you click on these, you can also go in and see the build logs for that specific phase, right? Nothing too fancy, but that's what we wanted. We wanted something simple that external contributors, even people who didn't know how to use the systems, can use. So we covered that requirement straight off the bat. All of the public CI systems offer this. We no longer had to maintain that CI server. It is a production system. It is yet another production system we would have to maintain. So if we no longer have to do it, and we can give that to some company who just wants to solve CI. We don't just want to solve CI, right? We want to solve API management in this case. So we can focus on solving that part rather than the CI. So that's a big tick on our list. Then, as we get kind of into more details, the more complicated a pipeline gets, the more important it is to be able to rerun only parts of it that failed as you're trying to debug it or verify some problem or solution you have put in place. If you have this really long pipeline that you can see here takes 10-20 minutes, when you get to the end and only this part fails, right at the very end, the last thing you want is to have to go through this whole thing again and wait another 20 minutes just to get to rerun that part, which is the one that caused the failure. Being able to use this rerun from failed option, which is something we also had in Jenkins previously with the restart from stage. It's called in Jenkins pipelines. It really helps you get to the root of the problem faster. Talking more about debugging CI failures, I mean, there are some times where build logs are just not enough. So the first thing we would ask of our ops team that was maintaining this Jenkins server and the Jenkins workers and all this automation in place was, can we have SSH access into the worker where these tests are running? And some of the public CI solutions today do offer this out of the box. So you can, when for example, when you have a failure, you can go in to the job and you can choose to rerun the job with SSH enabled. And this runs the whole thing again, enables an SSH daemon, and gives you a nice, easy, you just copy paste an SSH command from your machine. You log into that container as it is running your tests, at which point you can run any shell commands. You can monitor the processes that are running. You can even connect debuggers into those running tests. And it's a simple but very, very helpful thing to have as you're trying to debug these failures. The next slide. The final problem we were able to solve with going to these public CI solutions was that we were finally able to bring down the costs. After we went through all this work, migrating to the containers that were running our test suite now, and did all this migration into the public CI system, we found that the monthly cost we were paying for the cloud infrastructure is basically half. We went from around 2.5 to around 1.2K. Obviously, this varies per month because of the different people working. When people go on leave, there's less expenditure, and But the important thing here is that not only did we reduce the cost by so much, but during the time that this migration was happening, our team grew. So this doesn't tell the whole story because we had about twice as many builds happening with that reduced cost. So that's a really, really big reduction and improvement and kind of efficiency, really, overall. We were just wasting a lot on that previous solution. A lot of the problem has to do with EC2 billing being per hour, whereas billing on most public CI solutions is per minute. So that's already a big difference in the costs. But also the process of optimizing the pipeline and ensuring only the things you need to run are run with every test or every stage, that's what kind of really enables you to bring the costs down. So let's get back to the parallelization, and which is one of the main things that enable us to get this cost reduction. We're now talking about the parallelizing the tests, which was the second kind of level of parallelization we had within a specific phase, right? We now have these 1022 tests, and we want to group them into an arbitrary number of containers, so we can run these 1022 tests in parallel. The way you would typically split these tests. The simplest one you can use is just use an alphabetical ordering. The first one's going to the first container, the second one's and so on. But there are also other kinds of static grouping that you can have. And this static grouping, we typically find it in, for example, Maven phases. So people will have different tests running in the Maven test phase rather than the Maven verify phase. JUnit has support for categories, so you can create kind of by manually tagging tests to add them into these categories, and or you can use just different folders in your file system. And you run the different tests in different parts of your pipeline. But I'm sure if you're following along up to this point, it's obvious that this isn't the best solution, right? Because wouldn't it be great if we knew how long each test takes, so we can then use that information to decide how to group it, how to create the grouping of these tests running in parallel, so that we can expect them to finish at the same time. And it turns out we can. As we're running the tests, we can record how much time each of the tests take. Most of the testing frameworks support some kind of recording, and they also allow you to export it in a industry standard format. So kind of JUnit or XUnit XML report. We're not talking about the framework, but kind of the report format. And once you have this information in a report, so which says that this test took this amount of time, you can then go in and feed it into your public CI system. which allows you, Circle CI here, for example, and Circle CI and Shippable both have some kind of support for this that allows you to use the timings of the tests to predict how to group them so that they will all finish at the same point in time. They will all more or less take around 3.5 minutes. We won't have this case where one kind of container here might be running for 10 minutes while the others are running for 2, and we have to wait those extra 8 minutes. Let's come back to this. Please, if you have some questions on this, I'm not going into, too much detail, but if you have questions on this, let's keep them and discuss at the end. I have an example here of how you can do that with a command line tool that Circle CI in particular provides. So maybe we can come back to that later. Now, so we talked about this, that there are these 2 levels of parallelism, and we can see it here in this kind of screenshot. So there's this pipeline that has these stages, which is the first level of parallelization. Anything you can see vertical, so one under the other, it means that these are running in parallel. And when there's a line across, it means that this needs to run after this one, right? But these 3 are still running in parallel. These 3 are still running in parallel, right? So of the whole pipeline, we have some parallelization going on there anyway. Now, there's also this second level within these specific phases that we have these multipliers on. We are splitting the tests within that phase into separate containers. So there are 3 containers in this one, 8 in this one, and this one is the one with the 40. This is the really heavy one. Right, so for each of these phases, we are also doing the splitting so that this phase finishes faster. So, it may all be sounding great, but of course, as with everything, as engineers, we always expect there to be some trade-offs. And for us, one of the important things is that even though we're talking about open source projects and the fact that public CI solutions have free offering for open source projects, that's not always the case when there's a company behind the open source project, which makes sense. I'm against that. So, but there is still some cost involved. If someone's coming from a Jenkins background, where you're really used to this flexibility with plugins and kind of, being able to kind of pick the things you want and extend very easily your Jenkins to add this new functionality, you won't find that with these products, the public hosted CI solutions. There is a same kind of process as you would expect anywhere else. You have to request for them to put in a request for enhancement and wait for the company to kind of put it on their roadmap and kind of improve and provide the same sort of functionality. At the same time, you lose this great advantage of Jenkins that it's open source. And if I really want to, I can go in and dig into the source code of Jenkins itself or the plugins and fix whatever's broken and contribute it back to the community. But open source is also important in general. In Red Hat, when choosing any solution, it's a big plus if it's open source. Now, enough talk about CI. Let's switch a little bit to talking about tests. Because we did mention flaky tests, and I want to go into a little bit more detail, because if we didn't fix this part, we would have never gotten to the point where we can optimize the pipeline and we'll just, if it's still unreliable, we're not really fixing anything. One big category of problems with flaky tests and kind of non-deterministic behavior has to do with dirty state. When we talk about dirty state here, if we have tests that rely on state, for example, rely on some external database, on some files, in the file system, whatever, it's important to ensure that there's no leftover state from previous tests. But if we leave it up to the tests and the developers to clean up after the test, it can always happen that some test doesn't clean up after itself properly, and this creates an inconsistency in the state that the other test expects. Or another problem, because the thing is, we can't always start with a clean database dump before each and every test. In theory we can, but it's just too expensive, too slow to do that. So we need some kind of other way to catch these problems and ensure that all state is cleaned up. One way to do that is, for example, to use database transactions where possible, not always possible, and ensure that at the end we simply just roll back the transaction. We never forget to delete the row that was inserted, or we can simply create new workspaces for each independent run. Right, those are ways to address this problem without having to rely on cleanup. As for now, reliance on tests and kind of dependencies between tests, which is another problem that we can often see that also causes kind of flaky test behavior. You might notice that this third test only passes if it happens to run after the second test, or maybe this one only happens to run after the first test. Only passes when running after the first test. And many engineers, many developers expect this kind of behavior from their test code base. They expect that the test they wrote, they will always be run in that order, which is why they only set up, once at the beginning of the test class, and then all the tests in there, they expect them to always run one after the other. So there's a clear dependency there. And this is fine unless you want to take these tests. We were talking earlier about parallelizing these tests. I would ideally like to take this first test and second test and third test and potentially even run them in independent containers, because that's what allows the whole pipeline to finish faster, right? That's what we're trying to solve here. So these dependencies can be a problem. Or another way these dependencies may break, usually the order tests are run is alphabetical. So, for example, this is especially true for test classes. And you might notice that a new class was introduced. None of the code of the class before and after it was changed, or the production code. Neither the production code, neither the test code, but the introduction of this class, simply because it happens to run in between the other two test classes, somehow breaks things. And if you want to ensure that your tests can run reliably, you need to go through this kind of exercise of randomizing the order that your tests are run in. Make sure you randomize a lot, like you try this many times, like hundreds of times. And what you're really interested to see in those runs are the failures. So when you do get a failure in these, 100 runs, which in theory should all be passing, right? Because the order the tests are run shouldn't matter, going with that assumption. When we do find failures in these, 100 runs, we don't care about all the successful runs of the test suite, but for the failures, it's important to first be able to reproduce. So make sure we know what order the tests ran, right? So it's at least printed in the logs. Try to reproduce that in a local environment. So we have, first step of debugging is reproducing the problem, right? So be able to reproduce that and then kind of split the code base in half. Is the problem happening in this part? Is it in this part? And kind of bisect your way through down until you get to 2 or 3 tests, test files, classes, tests that show this problematic behavior. That's when you found this dependency, and that's when it's worth kind of then looking into the code. And usually the problem is then pretty obvious. It's tricky finding what the problem is. Because the failing test is usually not the one with the problem. Some other test along the way has created this inconsistency. So that's our way of kind of isolating the test and then fixing the problem in the cleanup or setup of that test. But I think it's kind of really important to focus so much on the test code base and think about the tests from this perspective that we want them to be able to run in parallel. We want them to be absolutely reliable because it is a production workload, because we ourselves are the customers, right? And first of all, we should make sure that we have this. And even great sets of principles like the 12-factor app, right, by Heroku, I don't think they put enough emphasis on the test code base as much as they do to the kind of regular production code base with kind of deployment and so on. I think there's room there to recognize CI as a different kind of workload that is executed in a kind of different part of the life cycle. So I'm proposing there for the 13th factor to be added. Now, once you have gotten to this point where you did go through all these flaky tests, fixed all that, there are several improvements you can make to, apart from running your tests in parallel, there are other things you can fix too. One of those is dependencies caching of dependencies. When I talk about dependencies, we might have, the external dependencies, so, libraries that your project uses, or we might have internal dependencies in between the different pipeline stages. As for the external dependencies first, first and foremost, it's important to have those, recorded somewhere in some dependency file, your POM.xml, gem file, package.json, whatever. So you know which exact versions of dependencies you're always using. The great thing with that is that once you have that file, it's then fairly easy to detect when that changed. Did the dependencies change between this build and the previous one? If you're working on a pull request where your git log looks something like this, well, I hope not. Hope you're using more meaningful commit messages. But if neither of these commits actually change the dependencies, you wouldn't expect your CI for every one of these runs to go in and reinstall the dependencies, right? Re-download everything from the internet. In some cases, you also have to compile while you're installing dependencies. So that's wasted compute time if you're doing this over and over. when the dependencies didn't change. So when you have that file, it's very easy. You just hash the file and you just check in the next run. If the hash didn't change, I know the dependencies haven't changed, so I don't need to run that pipeline stage. I can just use whatever I had in the previous run. And public CI solutions today do offer that kind of functionality for caching dependencies. The same goes with external dependencies. When we're talking about running these tests, these groups in parallel, the last thing we want is for each one of these groups to have to re-download the dependencies, install them, and then start running the tests. We can only do this once at the beginning of the pipeline, and then the later pipeline stages can reuse what was an artifact that was created in the first stage. And these are then the internal dependencies. These artifacts used inside the build, they can be the dependencies, the libraries. They can also be transpiled assets and kind of a bundling that can happen in these builds. But yeah, there's really good support for caching between builds in most CI systems, hosted CI systems. And of course, you can also do it on Jenkins as well, right? So with that, I want to kind of shift the discussion a little bit to a couple of things that I think are worth pointing out with regards to the future of CI/CD. And actually, the CD part is kind of crossed out on purpose because, as I've mentioned, throughout this talk, I've only been talking about CI, not the deployment part of the pipeline. Whereas most systems today use the same kind of, offer the same kind of tools, like a pipeline that's supposed to solve CI and CD. And as the practices around CI/CD are maturing, I think there is some space being created for systems, solutions, products that just solve CI, not CD. I would be very happy if there was a niche product that said, we do not, we don't solve, deployment into production. Let's, use another tool for that. And this is because CI has very different needs than CD. The deployment, if we compare, a deployment can be very, very simple compared to, finding the optimal way to orchestrate this compute workload of tests that we have to run. We have to, install dependencies, run tests, create packages, binaries, set up, set up containers, deploy into containers, test against that. And it's kind of a really complicated thing, after which we then go and say, okay, now this binary we produced is okay, deploy it into production. Usually the deployment compared to everything that has run before, I think is very, very simple. Or that's just my experience, we can talk about it in the end. I'd love to hear some different views on this. So then CI should care about executing the tests as fast as possible. That's what it should solve. I don't necessarily want to go into the pipeline, even everything I talked about, in this talk about creating these separate test stages and kind of forcing me to, tell the CI system which way is the best way to run my tests. Why couldn't a next gen, CI system solve that for me? The great thing about CI is that it's a production workload with very predictable patterns. So, your you mostly know that the tests you run last time, they would probably be the same this time around too. So I think there's going to be, I feel there's going to be quite a lot of potential for optimization on the kind of service side of the CI to create some kind of offering. And yes, I mean, there's really no reason why, when talking about CI, we should be focusing on pipelines. Which, I mean, even the kind of newer systems coming into play now, the Tecton project or OpenShift pipelines, which is the kind of Red Hat product. Tecton is it's a Kubernetes native CI/CD solution, and still kind of focuses on pipelines and tasks, but not really on tests. And when I talk about focus on tests, what I would expect is for one of these systems that I could just give it my credit card and my tests, my test code base, and I don't care, just give me back the results. Here's my GitHub repo, these are my tests, they're in some framework that you support, so now it's up to you. You run them, you figure out how long they take, use some kind of dynamic test allocation, figure this out, right? Solve this problem, and give me the results. Give me the results at the end. What I care about as a developer working on the 3-scale team, on any product team, is working on the product, getting some feedback on the product. That I haven't broken something I didn't mean to as a service. There are obviously lots of other good practices with continuous integration, with having to do with the code base and kind of frequent merges and so on. I'm not going into that discussion, right? Just focusing on testing and kind of regression testing here. So yeah, with that, I'd like to kind of close it off, leave this with this final point. Love your tests, treat them as you do your production code base, because your tests do run in a production environment. It's not just a production code base that does. And they do run in a production environment where you and your teams are the client. So craft them with that in mind. Thank you very much. I'm open for questions for as long as we have.
Guys, do you hear me?
Yes, I can.
Okay, so thanks a lot. We have several questions. First of all, there was a question about what it was on slides. Is it Circle CI? So I think that we could answer yes, it was Circle CI.
Yes, it was. That's the solution we're using for the 3-scale project, and all of the config and setup. It's all open source, so we can kind of even go into detail, right? In this next session we have later, if people want to look at things, specifically, if they have questions about the setup, the Circle CI config we're using, why we're doing things the way we are, I'm very happy to kind of go into detail later. And
you can check the link. I've sent the link from the slide on the GitHub Freescale. So you can go to the GitHub of Freescale, click on build, and go to Circle CI. So you can check it right now. And Yorgos, there is a question from Galina Rasko. The question is, are you splitting tests between Circle CI Jenkins? How do you split Circle CI Jenkins jobs by runtime, manually, or there is a way to automate it?
We are running all of this. All of our upstream CI, we're running it in Circle CI. There's nothing running in Jenkins now that has to do with CI. we're still using Jenkins for some internal automation and how we create productized builds from the open source projects. But yeah, all of this CI for all our projects, all the 3-scale projects, is all on Circle CI.
So you are separated by vendor or how? How do you separate?
We're not.
I mean, which
We're not splitting anything. All the tests are running on Circle CI.
Okay. And the another part of the question: what about adding new tests? Should they manually be added to a specific job by runtime?
At the moment, this is what's happening. Yes, it would be added to this new phase, right? So we are either running some Cucumber tests or RSpec tests. This is Ruby project, the one in the examples. Actually, Rails, not just Ruby. So there are also some JavaScript tests that are running on for kind of front-end things. And yeah, so the people adding new tests will just add them into the respective kind of, part
manually or automatically?
Manually. That's all done manually, yes.
Uh-huh.
That's what I mean when I say there's still room for improvement in this space, because yes, they are getting assigned to containers when we're splitting them in parallel. Yes, that is happening automatically. The split based on the timings data of we have from historical data, but the assignment into a specific stage, the kind of first level of parallelization, that's what's happening manually. The second part, which is which of the 40 containers does it run in, that's completely automatic because we don't do anything about that.
Okay. Another one question. Thanks. Another one question is from Maria Spirina. What kind of tests are part of the CI approach? Are there any integration tests?
Yes. In fact, the kind of the heaviest ones, the 40 containers example, those are all integration tests. And when I say, actually, that's a good point for clarification. When I say 40 containers, not really containers, but more like pods. So from the Kubernetes space, it's actually groups of containers. So we have a container of the application, a database, a cache, and whatever group of containers, we have those in 40 different environments. And we're running integration tests against that deployment. In each of the 40 containers, a subset of the tests against that environment.
So integrations, but internal integration, yes? Do you have some external systems in such testing?
Right. No. We don't have any kind of, if you're talking about contract testing, for example, with external API solutions, no, we don't have any of that in place. As far as I know, maybe some of the other projects do this, or components of 3-scale, but as far as I know, we don't yet.
Okay, so another one question is, do you know any public CI which can support exotic platforms like Solaris, IBM X, etc.?
That's a good question, but addressed to the wrong person. I've been lucky enough not to, not have to deal with exotic platforms. Only an exotic island. So I don't know.
But Circle CI doesn't support, yes, Solaris, for example.
I don't know. That's actually something to say here. There's no affiliation with Circle CI, right? Between Red Hat or me and Circle CI. We're just using that as the third solution, happy customers, that's it.
Okay. And another one question from Galina Rasko. What gem do you use for Ruby projects to parallel tests?
That's a nice question. So there is a gem that can actually do better than what we're doing today. There's I can't remember the status of it. I think it's an open source project as well, or it has some kind of offering for open source projects, so Knapsack Pro, that actually allows you to do this dynamic test allocation that we don't do today. Our allocation of the 1022 tests to the 40 containers, it happens statically, so that means before we kick them off, before we start these 40 deployments and the integration tests against them, we statically, or not we, but Circle CI statically assigns them to these 40 groups, and they start, and they may or may not finish in time, depending on what actually ran. But there are gems like Knapsack. So Knapsack is spelled with a Knapsack, Knapsack, which allows you to kind of have all your tests in a queue and kind of pull tests one by one by all these workers and kind of make sure your tests would finish even faster. But I'm not sure. We did consider using that. I'm not so sure how much the benefit would be when you do have this static grouping of Circle CI. It's definitely better. I can't quantify it, and I'm justified.
Okay.
If anyone has any experience, I'd love to hear it later. I'm actually really interested into that.
Okay, we can discuss it in our discussion zone. And the last one question is from Natalia Kovtsur. How to improve deployment time? Now we encounter unpredictable deployment time during Moscow time. We have distributed teams. So how to improve deployment time if you have distributed teams?
How to improve deployment time when
you have a distributed team. You have several teams all over the world, and they want to improve deployment time. So how to do it? What do you suggest?
Yeah, I'm not sure exactly what the problem is related to the deployment teams. Maybe some to the distributed teams. Maybe we can kind of take it to the discussion later. I don't really understand the question. Maybe some clarification can come.
I could clarify. For example, you have a team at USA, you have a team in Greece, in St. Petersburg, and you have only one pipeline.
Yeah.
So you have a bottleneck, and that's a problem. Yeah. So you should separate pipelines, or you should choose some time for deployment somewhere in the middle or something like that. There are a lot of decisions, but the question is about this.
Yes, I have to say we are a distributed team. So about 30 people working on the engineering team in 3Scale are kind of based all over the world, probably across 7-8 different countries. We don't really have that problem today, so I don't know. Yeah, maybe if we talk about it more, we don't have that problem. The deployment is kind of,
so
maybe we don't deploy.
So Yorgos, if you let me interrupt you, because we've got 15 seconds for me and for our people to thank you and you to Avenir. Yorgos will now go to Zoom room for discussion zone, and Avenir will follow him after a short ad after VTB and Contour. Thank you.
Thank you. See ya.